Robots excel at repetitive tasks in controlled spaces, but still struggle in unpredictable environments like an office or home.
It has a specific skill and it has a kind of brittle skill in some sense. So if anything about the environment changes that doesn't conform with what was planned for ahead of time, then these skills tend to fail. We need like a way for the robot to adapt to the situation at hand without having a human pre-program every behavior that the robot is supposed to do.
The challenge of training robots to solve problems through reasoning has been taken up by a consortium of roboticists from the world's leading labs. This lab at the University of California, Berkeley is one of them. Think of it as preschool for robots.
I've just entered the instruction, put the mushroom on the towel.
This robot arm is following a command and at the same time generating data about its reasoning process.
So it just failed to pick up the mushroom and it's realized that. So it's sticking to the subtask to go to the mushroom and grab it.
If successful and the reasoning is sound, this data can be used to help other robots with similar tasks. Labs in North America, Europe, and Asia are sharing their control data, which, along with data from the internet, will train an LLM, a large language model similar to ChatGPT, essentially one brain that can control a wide variety of robots.
So basically, if I teach one robot arm how to pick up a Coke can, and I have another robot arm that has never in its life seen a Coke can, it suddenly understands the concept of what a Coke can is, and it has a chance of actually picking up that object itself.
Learning how to identify a Coke can comes from vast amounts of visuals and text gathered from the internet, as does being able to pick out Taylor Swift from this lineup.
A lot of these concepts of like, oh, when the Coke can is full, you need to apply more force and you need to lift it further. Or if there is a spill on the kitchen table, what you need is a sponge or a cloth to clean it up. These are concepts that you can learn from the internet. You don't need to learn them from a robot doing stuff.
Research shows the multi-robot, internet-trained brain is outperforming robots trained independently, says Perch.
Even the best baseline, the best model that they could produce was not as good as the model that we could produce by training on all the data sets together.
Many robots have very specialized uses and designs, so a general robot brain is not intended for them. But, Perch says,
for all the robot arms, or like all the household robots, or all the humanoid robots, eventually I think you will have essentially one model that serves as the base model to control all of them.
We may not see them in homes in the near future, but robots are making great strides forward. Matt Dibble, VOA News, Berkeley, California.